So once again, we were not very successful in the second model, as we discussed that reconstruction is not from substantive as well as statistical point of view very important predictor. So that's why I would propose to take new one regression model that would replace reconstruction by the fact whether the flat is new or not. Maybe it would be slightly better for this first introduction. So once again, let's go into regression. Linear regression, price will be dependent, C size, the first independent is covariate, and new one or old one flat, so it means once again binary variable coded as 0, 1 will be as factor. So here we have the first results. Once again, I would go into model coefficients and I would ask once again for classical set, so it means Anova test, confidence interval for unstandardized estimates. And we can also ask for standardized estimate. There is also one more option, and if you like, you can ask also for this, that also for standardized estimate, you can find confidence intervals here. So you would get also 2 more columns for these standardized estimates. Maybe one more comment to standardized estimates. It is quite common, and you can find it also in some statistical packages. These standardized estimates are called as betas. So beta has 2 meanings in linear regression model. It could be population estimate. It means unstandardized population estimate, and it can be also standardized estimate for sample data. So it is somehow a mixture of meaning of the same symbol beta in linear regression model. So here we are, and if I go very quickly through previous results, so we can very simply find that the first model with size or C size only has R-square 0.47. For next model with C size and reconstruction 0.474, so very slight increase. And currently for model with C size and whether it is new or not so big, but still a bigger increase to 0.5. So it seems that whether flat is new or not helps a little bit more than whether it is reconstructed or not. And of course, maybe there can be another problems that maybe we have quite small amount of new flats in our sample, maybe that somehow variable new and C size could be somehow related, maybe the new flats could be smaller or bigger on the average. So these phenomena can also influence these results. Maybe first of all, to see the discussion about the proportion of new and old flats, I would go back into descriptives and I would ask also for frequency table for new variable. Here it is. And you can check very easily that the proportion or even total amount of new flats is very small one. We have only 6 new flats. So that's why maybe your results for the variable new will be not very reliable. So we should know also about these facts. And the reason why I go every time to descriptive statistics before computation of linear regression result is very simply, please, every time before you start to compute some advanced model, let's try at least to see descriptive statistics for original variables. And of course, if necessary, define missing values, etc. So we would go back to our final results, and we would try to interpret these results. So we know about increase in R-square. So currently it is true 1/2 explained variance, 0.5. We can also find by Omnibus Anova test that both variables can help us to interpret dependent variable. And once again, the most important result is a set of model coefficients. So intercept is slowly shifted, but still the value is slightly below 900,000 Czech crowns. And once again, my question, I know that it is maybe too simple, but if somebody can help us to interpret this intercept, it will be very nice for me. So what is the current meaning of the intercept for our model? This is the average price for flat.
With average size that is not new.
This average size, which is not new. So it means zeros for C size and 0 for new. Yeah, definitely. So we can call it as old flat for simplicity. If I remember well, definition of whether the flat is new or not was that it was constructed in last 10 years, this house in which there is a flat. So here we are. That's it. So I guess we can simply omit the discussion about intercept, C size, and all related stuff. And we can go briefly only into the last row for whether the flat is new or not. So first one is the information that if the flat is new in comparison with the flat that is old, so the change in the average price would be nearly 500,000. So it's from substantive point of view, if we know that the average size for flats for average price per flat with average size is approximately 900,000 Czech crowns. So this is quite a big amount of money, which is increased for new flat. So this is at least from the first insight, quite important value. But be careful maybe about overestimation of these estimates, as we can go very quickly into 95% confidence interval, and we can see that the increase by new flat could be as low as 250,000 or 750,000. So you can see that confidence interval are quite wide. And my question is, what can be the reason why this 95% confidence in so wide?
The small sample of new flats.
Yeah. Definitely, at least this proportion, and also maybe not only the small sample, but also big differences between these 6 new flats with their increase to average price. So that's why, once again, this result is not fully reliable. So 6 flats are only behind this computation. This is not very good, I would say, and maybe that for statistical reasons, we will try to avoid such variable. But at least it works somehow, so I would take it as it is currently. With the warning, we have very small or limited number of new flats. Okay. You can see that from formal point of view, so if you take estimate, divide by standard error, and compute t-value statistics or evaluate by p-value this partial t-test, so we can say, okay, it seems that new flats are somehow more expensive than old flats, at least based on this testing, it works. And you can also recognize very easily that the importance of new flat in comparison with C size is even bigger by standardized estimate. But once again, do not overestimate these values. And maybe this is the first time in which I would ask also for confidence interval for these standardized estimates. So let's go back and ask also for 2 new columns. They will be totally on the right side. So here we are. And we can see that maybe the impact of C size and new could be comparable according to these values. So do not overestimate results based on small amount of units. It would be maybe my recommendation here in this diagram. So here we are, and we know at least currently that we can combine these two variables together. So it means C size and new into, I would say, currently the best model we have performed previously. Okay, so that's all. And I would go back into the presentation. So here we have discussion about outputs as we discussed all of these. So I guess we can skip this slide. There is also some special option in our regression. Let's check it only here in Jamovi. I'm not sure whether it is included. So give me a minute. Here it is not included. Model coefficients, that's not it. So I guess that we will go only very quickly through this information, as it seems that Jamovi cannot perform this procedure. At least I guess there is no such option. So I will show this option in SPSS. So I will skip this slide about forward, backward, and stepwise procedures later. And currently, I would go to the discussion of dummy variables. So we know, at least from first three models, we applied that our independent variable could be cardinal or could be binary. And if we would like to use nominal or ordinal variable as independent, there is also the option, and the option is called apply so-called dummy variables. I can go back into data matrix, and here we have the variable which is called city size, and it is based on, I guess, 4 codes. Code 1 is for the smallest villages, and code 4 for the biggest cities in the region. So that's classical ordinal variable. And instead of using this classical ordinal variable, at least for some statistical packages, I know that Spss and Jamovi can overcome this problem automatically, but we will learn about it later in logistic regression. It is good to prepare the set of so-called dummy variables. So dummy variables are binary variables that differentiate individual categories from original, nominal, or ordinal variable you would like to apply into your regression model. So instead of city size, currently here in my data matrix, I prepared for you variable, which is called size2. So it means if there is flat in the city size with code 2, there would be 1. In other cases, there will be 0. Let's check whether it works. So I would try to find some flats coded at 1. Here it is, size 2 is 1, and you can see city size is 2. So this is city size 2. If you would like to prepare this size 2 and other dummy variables, we can perform this by transform procedure. Let's go back to the first video. We have learned how to transform data. So that's size 2. Here we have also the variable size 3. So it means it would have code 1 for those flats in city size category 3. Here it is, and it seems it works. And for all other cases, 0s. And the last one, the same style, prepared variable is size 4. So it means it would include code 1 only for those flats who are from the biggest cities. So in city size, there should be code 4. Let's check it, and it works. So by 3 transformation procedures, or via SPSS by 3 recodings, you would get these 3 dummy variables. And maybe the question is, why 3 if original variable has 4 categories? So the general rule, and it is also described here on the slide, is that number of dummy variables must be 1 point lower than is original number of codes for original variable. So you must omit 1 variable or 1 original code. And the question is, if we are back here in synthesize 1, 2, 3, 4, why we should omit the first category? So for the first inside, it's necessary to omit some category. And the question is, which category should be omitted? And the easiest recommendation, at least for, I would say, easier interpretation of final result is, let's try to omit the category for which there would be the lowest level for dependent variable. So it means I would propose here to omit the category of city size for which there would be the lowest average price per flats. And I would expect that the lowest price of flats would be for the smallest villages, coded as 1. So that's why I am not preparing here the variable size 2. If I decide to omit some category or to omit some dummy variable, and once again, I must omit at least 1, it means that I need to remember which category is omitted. And the reason is that all results I will be computing will be relative, and we will compare all these results to omitted category. So the meaning of dummy variables is replace original k codes by k minus 1 dummy variables, and omitted category, omitted variable will be called as reference category for which we will be using comparisons. So all results for size 2, size 3, size 4 will be relative compared to the size 1, it means to the smallest villages. So that's the first insight. And before we would go into real-life computations, once again, I would give one more recommendation or one more analytical trick. If you find, and maybe we will be in such a situation in a few minutes, that maybe size 2 cannot be differentiated from size 1, or maybe size 4 cannot be differentiated from size 1, etc. So maybe we can reduce the number of dummy variables into also lower number than k minus 1. Only if we would omit some more dummy variables from the computation, then the base for the comparison or reference category will be changing. So we will discuss about it in a few minutes. So that's, I would say, theory about dummy variables. And this style of dummy variables coding into 0, 1s and omitting 1 category is classical style for many statistical procedures. And once again, at least Jasper and Jamovi can do it for you automatically, as far as I know. So it wouldn't be necessary to transform data and prepare these codes. Only in regression, you would apply nominal or ordinal variable, and Jasper Jamovi will do it for you. We will learn how it works in logistic regression in the next lectures. So that's about Jamovi and dummy variables. Okay, let's see how it works. So I would propose to go once again into analysis, regression, and linear regression. For simplicity, I would propose currently that we would take, of course, prices dependent variable. For simplicity, I would take C size as the only one independent currently, and I would take size 2, size 3, and size 4 as factors. Size 2, size 3, and size 4, and we would omit whether the flat is new or not for this first inside. And once again, to see substantive results related to coefficients. So once again, I would ask for Anova test, confidence intervals, and standardized estimates. So here we are. And here we have all results. You can see that our final table related to model coefficients is quite a long one, but I guess it wouldn't be too complicated to read. So first of all, let's go back to previous models. If you remember, R-square 0.47474, 0.5, and currently it's quite a big increase, 0.72. So currently, we are explaining nearly 3/4 of the variance of prices based on sizes and city size, or category of city size currently. And that's quite a good result, according to my opinion, as you have only 2 predictors. If I take into account that originally there were 2 variables, and we are able to explain 3/4. So that's quite good result. And we can go very simply also into Omnibus Anova test to this detailed table. And it informs us a little bit about the final conclusion of the story. So it says, okay, city size, size which is centered for size of the flat seems, from statistical point of view, significant, at least p-value is low. For size 2, size 3, it seems that p-values are quite big one. So maybe that these 2 groups are not differentiated from size 1. So it means from the smallest villages. And for size 1, size 4 result seems promising. So it means there would be some difference. So that's this Omnibus Anova test, which is quite detailed, and it would help. And we would see nearly the same story in this detailed model coefficient table. So first of all, once again, repetition is always good. Somebody could help to make interpretation for the intercept. So for 700, approximately 1,000 Czech crowns. So for which types of flats this is the average price. So maybe somebody from Zoom could help to know that you are not sleeping. So if you know, please help me. Do not wait.
So it is average price for flat with average size located in small villages?
Yeah, that's nice. I hope that you are able to hear it. Yeah? Okay, so that's good. So definitely, you're right. So it is the average price for average size and the flat in omitted reference category, city size 1. Yeah, definitely. Okay, so I would omit maybe discussion about C size variable, as it is nearly the same as previously. And let's go to size 2. So size 2, once again, is comparing the average price with similar size in city size 2 in comparison with city size 1. And from reading the coefficient, it seems that there is quite big difference, approximately 70,000 Czech crowns more. But you can see also that standard error is quite big one, and also that confidence interval is quite one, and going from minus 50,000 up to plus approximately 200,000. And also p-value is quite big one. So it means that from statistical point of view, and also substantively, this figure is not too big. It is approximately 1/10 of the value of the intercept. So the difference between size 2, size 1 is maybe quite low one. And from statistical point of view, it seems there is maybe nothing. So maybe that size 2 and size 1 cannot be differentiated at all. So maybe we could omit from our computation this difference. So it means maybe we can omit the variable size 2. For size 3, this is nearly the same story. also the coefficient is slightly bigger, approximately 100,000. So it's approximately 1/7 of the intercept value. But still, confidence interval is quite wide, going from minuses to pluses. And also the p-value, at least if you evaluate it by 0.05, is not promising some big statistical significant difference. If you compare also standardized estimates, so it means 0.665 for C size, and then for size 2, size 3, so these values are quite small one. Totally different story can be found for size 4. So it means for the bigger cities or biggest cities in the region. Here we have the difference, approximately 600,000, and it is nearly the same as the average price per flat with average size in the city size category 1. So that's quite a huge amount of money you must pay more. Of course, that confidence interval is slightly wide, but still saying that it would be approximately 500,000 up to 750,000 difference. So it is still quite big difference. And also p-value is quite impressive, so at least lower than 0.01. And you can also check that standardized estimate for size 4, so it means comparison size 4 to size 1, in comparison with size of the flat is approximately 2 times higher. So it is very important predictor, at least to distinguish size 4 and size 1. So if I sum up very quickly these results, my proposal would be, okay, maybe we should omit category size 2 and size 3, and we would only use for the model differentiation of size 4 against the others. So it means that new reference category will be size 1, size 2, size 3. So it means small villages, and small cities in comparison with the bigger cities. It would be our only differentiation here in the model. So we would make model simpler, as we would take only 2 predictors in the model. And I guess that the decrease in R² would be very low one if you take into account all previously discussed results. So I would propose to compute this model as the next one. So I would go once again to regression, linear regression. We would take once again price as dependent, C size as covariate, and size 4 as the factor. And once again, for model coefficients, I would ask for Anova, confidence intervals, and standardized estimates. So first of all, let's see whether the decrease of R² is not big one. Previously 0.722, and currently new one R² is 0.718. So it seems, according to my opinion, that these are nearly the same numbers, and still our current model is much simpler. So here we have the model. And once again, last one repetition today, sorry for that, is that somebody could help to interpret the intercept currently. So what is the meaning of the intercept? So maybe once again from Zoom users. Please help me. So what is the average price?
So it is average price of size with average size, of flat with average size, and located in small village.
Not in small village, but in villages and small cities.
Yeah, villages
which are not in size 4. Yeah.
Okay. Yeah.
Yeah. Thanks a lot. Okay. So that's it. That's the meaning of the intercept. C size can be also skipped. And currently size4 is the difference between the average price for the flat, which is in size4 and which is not in size4. It means which is in size 1, 2, 3. So currently we are comparing size4 to the rest. As reference category, our categories 1, 2, 3 together. So that's different. So if you decide to omit some of dummy variables, please be careful that your reference category is changing. So that's it. Here the difference is approximately slightly more than 500,000. At least that's rough estimate from my sample. If you like to have rough estimate for the population, it's slightly below 500,000 and maybe slightly more than 600,000. And once again, according to standardized estimate, this variable is very important though. So it is quite good to include this variable, 2 times more important than size of the flat. So that's also a very good predictor. Okay, and now last question that could be raised is whether this is the best model for these 2 variables or whether it could be somehow improved. And why I'm asking about this moment. So currently I'm saying, okay, what really matters is size of the flat. And for every individual square meter, you would pay approximately 14,000 Czech crowns more. And if the flat is in bigger cities, you would pay approximately 500,000 more. Doesn't matter whether it is for small or big flat. And maybe this is not the ideal version of the model. Maybe that if the flat would be small, the increase of the flat in bigger cities would be only 100, 200,000. And if it would be big flat, it could be maybe 1 million or more Czech crowns. So maybe it would be also good to somehow link size of the city to size of the flat and to take these 2 variables into some artificial effect. So that's my idea. Also, for previous model, if I go back, for example, to the discussion whether the flat is new or not, once again, this added value, approximately 500,000, was general added value for every flat, whether it is new, whether it is small, middle size, or big one. But once again, I guess that this added value should be different according to size of the flat. So also here, some combination of these 2 effects, it means size of the flat and whether it is new or not, should be applied. So these are, I would say, some preliminary ideas for brief discussion about so-called interactions. So currently, we will briefly discuss about so-called interactions. So if you have some doubts that not only individual effects of variables, but also some combinations of these variables should be included into your model, so you are applying so-called interactions. So interaction is the effect which is combining 2 or more variables together. If you like to apply interactions, also there are some exceptions in packages, but mostly it is necessary to prepare these new interaction variables into your data. From a mathematical point of view, it's very easy. Interaction is nothing more than, if I go back into data matrix, you take 2 or more variables and you multiply all of these into new created interaction. So that's how it works from a mathematical point of view. I guess that here through Model Builder, it is also option to make these multiplications, but I'm not sure as I'm not working with Jamovi. So I will show you classical way, which is general for all packages. So we will prepare such an interaction. And my first proposal would be, let's take the interaction for size variable and size4 variable. So it means we will be measuring the increase, not general for all flats, but for individual increase by 1 square meter, comparison of bigger cities and the rest. That will be our main goal. So it will be our first interaction. So we would use this model, size, size4, and we would add one more variable, which would be multiplication of size and size4. So if I go back into data matrix, so I would need to go into compute once again. I hope it works. And we would need to define this interaction. My proposal is simply to call it INTER as shortage for interaction. Once again, be careful to use more than 8 symbols or digits, at least generally, it's not recommended. And the formula here should be that we would take size, multiplication of size should be star, I guess, and multiplied by size4. And once again, be careful that all letters should be small one, size4. So I hope that currently it works. I will only try to check it. So for the first, there are zeros, the size4 is 0, so it seems it's correct. Okay, so currently I have computed variable for interaction. You can only very simply see that if you compute some variable, there is some black point here. So it means it is computed variable. So you can go back to the computation formula and change it. So currently this is new one variable. And if I go back, the easiest case currently is that we combine one variable that is cardinal, that size of the flat, and one variable that is binary. It is whether it is in size4 category or not. So that's the easiest. You can also combine 2 cardinal variables, but then the interpretation is not so easy. So we would skip this case. So here we are. We have prepared variable interaction. We have size and size4 in our data, so we can compute model, including interaction. Okay, so let's go once again back into analysis, regression, linear regression. And let's once again define the problem. So price as dependent. We have 2 covariates currently, size and also interaction, and size4 as the factor. Recommendation, but there are many discussions about this recommendation is that if you are applying interaction in the model, you should also apply all original variables from which you created the interaction. There is also an option to omit original variables, but mostly we prefer this option. So once again, I would ask for Anova test, confidence intervals, and standardized estimates. And we would check the model. So current R-square 0.74 is, according to my previous knowledge, the biggest one for data. So this is currently the best model we have performed, at least according to explained varieties. We can also preliminarily see in Omnibus Anova test that all these predictors currently, so it means city size, central size of the flat, and interaction seems promising. And we can currently discuss about results. So first of all, the meaning of the intercept is still the same as previously. So this is the average price per flat with the average size and flat, which is in category city size 1, 2, or 3. All zeros here. So that's easy. I guess that we can slightly skip C size, but I would maybe spend some more seconds on this C size value. So currently, this 12,000, this is the lowest value as far as I remember from the previous one, has slightly different meaning in previous, in comparison with previous results. Currently, this is the average price per square meter, or the increase in the price per 1 square meter for flats that are not in city size 4. So this is the average price for the flat in category city size 1, 2, or 3. So that's slightly different meaning from previous one. Previously, it was the average price for every flat from every category, but currently it is only 4 flats in category city size 1, 2, 3, 4. And the reason why is it so is that here we have the interaction, which is approximately 7,000. And it is saying that if you are in category size 4, remember that interaction was created by size 4 multiplied by central size of the flat. So for size 4, the increase is not 12,000 per square meter, but 12 plus 7, approximately 19,000. So the slope for flats in villages and small cities is approximately 12,000. And the price per square meter for flats in the biggest cities is approximately 19,000. Or if I discuss it maybe roughly, so it is approximately more than 1/2 bigger than original C size slope for villages and small cities. So this is the increase in the slope for the bigger cities. And now the question is whether it is understandable or not. So we have, I can say from interpretation perspective, 2 possible slopes. Slopes for flats in villages and small cities, and slope, which is sum of these 2 values for the bigger cities. And last one, size 4, is saying that still there is some difference for flats that are in for flats that are of average size. So if it is average size flat in category city size 1, 2, 3, the value of this flat would be approximately 800,000 Czech crowns. And if it is flat in city size 4, it would be approximately 500,000 more expensive. So approximately 1.3 million. So these are something like basis, intercepts, or constants, once again, different for these 2 city size categories. And I prepared a picture for this case. This is the case for new and old flats. So I computed another result. And you can see, if there is no interaction, there is only the difference between constants. So this one value for old and new flats was approximately 500,000. So if I go back, here we have the previous result. Let's go back. It is new. Here it is. And it was approximately 490 the difference. So it was for new one and old one flat. So this is no interaction model. So we are expecting two regression lines for old and new flats that are parallel to each other, only differentiating by this, let's call it difference in constant. If you apply interaction model, so here once again for new and old one, believe me that these results are correct, you would see not only the difference here, but also the difference in shapes or slopes for two types. Here we have old flats and new flats. Currently, we can apply the same style, so maybe I can make a copy and only add figures for our current results. So I would go down. Here we are. So here we are, the intercept and size 4. So 796 would be here. 796. Oh, sorry for this typo. 796 thousandths. And the difference for category size 4 is 5 to 7. 5 to 7, and slope for flats that are in villages and small cities is approximately 12,000. So 12, and here 12 plus approximately 7. So here it is, how it works. So you can see that this is the level of average size flat, so approximately 65 square meters. For this flat, the price in small cities and villages is approximately 800,000, and for bigger cities, approximately 500,000 more. So that's the base here for average size flat. And the increase for every square meter up or decrease down is approximately 12,000 according to a model to flats that are in city size 1, 2, 3, or villages or small cities. And for bigger cities, this increase is approximately 19,000 Czech crowns per every square meter. So this is graphical, and I hope so, very easy to understand interpretation of this case. But still, I can understand that this could be slightly complicated stuff. So if you have some questions, feel free to ask me, as I would be happy if you would be able to understand to all these results. So it means that you can imagine what it means substantive. And if I go back to our all previous discussion, this model, including interaction, is the most realistic model for data. So it seems that it is describing the reality quite well. Of course, that you can say, okay, still there are some predictors that are missing. Yes, definitely. But for both predictors that we have applied, so it means city size 4 and the size of the flat and interaction, we made everything that is possible in linear regression sphere. Okay, so some questions? Okay, so if there are no questions, so in last minutes, I would spend some time to see how it works in a SPSS environment for you to understand how you can compute the similar results in SPSS. So first of all, I guess that SPSS is already prepared for me. So I would need only to find data file. I'm not sure where is it saved for me. So I will try to find it. here it is, flat CSV. Only be careful if you like to save all these results. So once again, you can save it in OMB in Gmovie. So I would only click into save and to add to all previous results also these new results. So here we are once again in Spss settings. If you like, of course, you can close Gmovie for today. So I would close it. And currently, we will try to compute some of previously discussed steps in Spss environment. So first step, if you remember from previous discussion, was that we omitted the biggest flat. So once again, two options are possible. You can select only cases with size below 200 square meters, or another option is that you would omit big flats by missing values. For today, I would select this option. So I would go into missing values and I would type that values from 200, 200 square meters up to maybe 800 square meters will be omitted for simplicity. I would only check whether it works. So I would take descriptive statistics for price and size, and 261 cases should be included for size, and it seems it works. So here we are. So the smallest flat 18 square meters and the biggest one 179. So that's it. And if I go back into regression model, so analyze regression and linear model, so I can take price as dependent and size as independent. So it was the first step. And we can see very simply results from previous lecture for the first model. We know that for computational reasons and also for possible interpretation of constant, we change the size into C size. So if you would like to make this computation, here we have 64.655, which is the average for size. So I would compute C size variable. So let's go into transform, compute variable. Let's type that I would be computing C size. And I know that the original variable is called a size. I would subtract and 64 point, I hope that point would work. Let's see, 655. And let's click into OK. Let's check whether we have new variable, which is including data, and it seems it works. And the first flat C size value, second row, is minus 14.66. The next one, 17.35, etc., etc. Only I should mention that this C size is slightly different from C size in Gmovie. As in Gmovie, we slightly round up the mean value for the first decimal. Here, we are slightly more precise, but that's only a small difference. So currently, we can go once again back into regression and replace size by C size. And for comparability of results, I would propose to go into statistics and ask for confidence intervals here. So this is the second option here on the left-hand side. So here we are, and here we have results. And once again, constant or intercept can be interpreted here. So it is the price for the flat with the average size. That's quite easy. So that's C size and how it can be performed in SPSS. Next step we would like to show would be to add one more variable. So I would ask for variable about reconstruction. So once again, let's go into linear regression. You can see that SPSS is not differentiating independence into covariates and categorical data. There is only one window here. So SPSS is expecting that you have binary variable or cardinal variables, so it cannot somehow prepare for you dummy variables. Jamovi and Spss is capable of such procedure. So I will take reconstruction here into block 1 and click into OK. So here we are, C-size reconstruction. We know that R squared is nearly the same as previously. We know that reconstruction will not help a lot. So we can once again check that p-value, here it is called as significance, is quite big one, and also confidence interval going from minus to plus. So we have many doubts whether reconstruction should be added. And now it's time to go slightly back. As in Jamovi, as far as I know, there is no such option to find a discussion about automated selection of variables. So let's imagine for next minutes that we have a lot of independent variables, and we would like to ask the computer or a statistical program to select the best predictors for our model. So there are some automated algorithms. Once again, according to my opinion, there is no such option in Jamovi. JASP can help in this case in the same style as SPSS. And there are at least 3 possible algorithms for this occasion. These algorithms, at least in SPSS and also in JASP, are hidden in the first dialog. So if I go back into regression analysis, once again, here is the method. And by default, it is selected to enter all variables that are prepared for you. But you can also select alternatives. And I will briefly discuss about these alternatives, and we will perform at least some of these computations. So first one procedure is called forward, and it is following these steps. So if you take our linear regression case, C-size and reconstruction, so in the first step, it would compute correlation coefficient, price and C-size, price and reconstruction. And then select the variable for which this correlation is bigger. So I guess that C-size and price would be bigger than correlation, and SPSS would decide, okay, let's take C-size into our regression model. In the next step, it would be computing correlation between price and reconstruction, but taking into consideration also C-size variable and the relationship of price to C-size. So in other words, SPSS will be computing so-called partial correlation. And if this partial correlation is, from statistical point of view, good enough, it means it follows a statistical testing principle. So it means it is statistical significance. Also, reconstruction will be added to the model. If not, it will stop. So that's forward algorithm. If you use just opposite case, backward, it would follow nearly the same step, only as the first model, SPSS or another statistical package will include all predictors, and then it will remove predictors that will be based on testing of partial correlation coefficient statistically insignificant. And if there would be no such predictor, so it will be our final model. And combination of forward and backward approach is called stepwise. So it can include as well as exclude predictors. So it means it can go forward and backward. And final model will be, once again, the model for which all predictors will be statistically significant predictors for dependent variable. If you should decide whether to use forward, backward, or stepwise, and maybe it would be a strange answer for myself, I would propose you not to use any of these procedures. as these are automated procedures, and you as data analyst are totally out of the game. Only computer or some, I would say, silly algorithm is deciding which variables should be in your model. But once again, if you have maybe hundreds of variables and you would like to take some preliminary selection, it can be useful. But for some smaller models, as we perform today, I wouldn't recommend you to apply these automated procedures. And that's not only my recommendation, that's recommendation of distinguished statisticians all over the world, I must say. Okay, but as you maybe would like to see how it works, so I would propose that you, for example, to use, I would say, the very, very famous and favorite technique, which is called Stepwise. Once again, combination of forward and backward. And you can click into OK and see how it works. So here we are. And you can see that in the first model, C size was entered into the model. And you can see that reconstruction didn't enter into the model at all. And that's our final model. And that's not surprising because we know that reconstruction was quite poor. I can show you also the next one example to see how it works. So I would go once again back into linear regression. I would remove reconstruction and I would take size 2, 3, 4. And we know that by our interpretation and by our substantive results, we decided finally to take only size 4 into our model and leave size 3 and 2. And maybe we can try to ask this automated procedure to find for us the best model. So let's try whether it works. So here we are. So you can see here maybe more steps. And for the first step, you can see that C size was entered into the model. Then size 4 was entered the model. And that's all. No other variables were entered into the model. So final model by this automated procedure is the same as we applied previously by our, I would say, analytical common sense. So at least this is the proof that it works. This is a possibility how we can discuss about these results. So we can see that first model included C size, excluded size 2, size 3, size 4, and final model, C size, size 4 in the model, and outside of the model, size 2 and size 3. And the reason is that partial correlations are statistically insignificant, as you can see. So that's why these two, size 2, size 3, were not included in the model. So that's all about this automated selection procedures. For all regression procedures, so I mean not only linear regressions, but also nonlinear regressions such as logistic regressions, these automated procedures can be applied. So that's all about automated procedures. And last one step that we should briefly perform here in SPSS environment should be model with interaction. So if you would like to perform the interaction, so once again, I would take size 4 and C size. So you would go into transformation compute variable. I would call this variable once again as interaction. And I would like to take C size, multiply, so once again star, by size 4. Here it is. Here we have the variable, so we can check it whether it works. So here it is, interaction. So 0, 0, 0, as size 4 is 0 here. And if you go down, you can find here multiplication of centered size of the flat and size 4, which is 1. So that's a copy of the original C size variable for bigger cities. And if I would go into linear regression, I would once again change the method into enter. So I would take C size, size 4 only, and interaction. And this is our final model with the interaction. So once again, results. Constant, so it means the price for average sized flat for small cities and villages, approximately 800 1,000 Czech crowns. So here it is. This is the value like here. Here, this is the added value for bigger cities, approximately 500,000, And here we have C size value, which is once again slope for villages and small cities. And here added value to slope for bigger cities, approximately 7,000. So it seems it works. So that's how we can perform computation with interaction via SPSS. So that's all for today from my side.